Today I am going to discuss 2021 5/7/22 Cambridge O-Level paper. Let's go to the question number 1. Question number 1 in section A, as you can see, it's all about the basic organic compounds. You have alcohol, a cyclic alkane, carboxylic acid, again alkene and alkane, carboxylic acid with alcohol, ester, alcohol and NH2 group. Part 1a. State which compound has a molecule with only 11 atoms. Answer goes to C. You can calculate the number of atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 11 atoms. So answer goes to C. Is oxidized to form ethanoic acid. So as you know, ethanoic acid formula, ethanoic acid is CH3COOH. So in order to obtain CH3COOH by an oxidation reaction, the reactant definitely should be alcohol. Which alcohols to get 2 carbon definitely should be ethanol, which is C2H5OH. So the C2H5OH, if you find, that is going to be answer A. Going to part 3. Is an isomer of butene. Butene you have meth-prop-but, 4 carbons, C4H8, butene. So the C4H8, you have to have 4 carbons and 8 hydrogens. 4 carbons and 8 hydrogens. Answer goes to B. Part 4. Reacts with hydrogen in the presence of catalyst to make alkane. So as you know, alkene reacts with hydrogen. Alkenes with carbon-carbon double bonds reacts with hydrogen in an addition reaction in the presence of a nickel or platinum catalyst to make alkane. Hydrogen addition reaction. So that should be alkene, which is D. Going to part 5. Contains 4 different elements chemically combined. 4 different elements chemically combined. So if we consider the structure H, I have hydrogen, I have oxygen, I have carbon and I have nitrogen. So 4 different elements chemically combined, therefore answer goes to H. Let's see pH of less than 7. You know pH less than 7 goes to acidic. In other words, the question is asking what are the carboxylic acids. In these 2 structures we have with carboxylic acids going to be structure C and structure F. So this is your acid group, carboxylic acid. So this is your acid group, carboxylic acid. Therefore answer goes to C and F. That's all about the question 1 in part A. Moving to question 2 in part A. That's about the group 6 in the periodic table. As you know, group 6 you have oxygen, sulfur, selenium, tellurium and polonium. Okay, group 6. State the percentage composition by volume of oxygen in dry air. So I should go for that one as 21%. It's a very basic thing you need to know. Actually, in fact, that is going to be 20.94%, but I'll go for 21%. State one large scale use for oxygen. So there are so many large scale uses. The main thing, I should go for the respiration. One example for the main use is respiration. In addition to that, commonly write in oxygen therapy would be okay. And we get for the oxyacetylene flame in welding, So just write in welding will be enough. And for the steel industry, so we required in the steel industry. At the same time, we required life supporting systems such as aircraft and diving. So any one of yours will be enough to get 1 mark. Okay, moving to the other one, two isotopes. Isotopes are very fundamental discussions in your syllabus. Isotopes. Explain why both isotopes have the same chemical properties. So you should know chemical properties are mainly dealing with electrons or the basic electronic configurations. As these both have same number of electrons, therefore same electronic configuration, it does have the chemical properties which is very similar. Okay, therefore answer goes to number of electrons are same, or you can say same electronic configuration. Right. Give one difference in the atomic structure. One difference in the atomic structure of these two isotopes. One difference in the atomic structure in two isotopes. One difference. So here the one similarity in number of electrons. I am going for the difference. So you know the number of protons are equal, but mass number different. Mass number difference basically due to a number of neutrons are different. Number of neutrons are different. So that is a big difference in the isotope. Going to part D now. Asking empirical formula. Giving you 9.6 oxygen, 82.8 chlorine, but question says you have selenium, oxygen and chlorine. So what you need to do is usual question in the exam, calculating empirical formula. Get the selenium, oxygen and chlorine percentage by mass. So which is given over there. Oxygen given as 9.6 and chlorine given as 42.8. Selenium is not given, therefore you have to calculate it. So as you are given total 9.6 plus 42.8. So that will end up with 42.8 and 9.6. You will end up with 9.6 plus 42.8 is equal to 52.4. So you got the 52.4. So then what you need to simply subtract 100 because total is 100, 52.4, then you will end up with 47.6. So that is your selenium amount. We'll write over there 47.6. Now you need to find the number of moles. So by dividing its atomic mass, so this should be divided by 79 and 16 and 35.5. You can find the atomic masses from the periodic table. You will end up with the simplest mass molar ratio now 0.6025 and you got 0.60 and you got here 1.2056. To find the simplest formula, the empirical simplest formula, divide by the smallest number 0.60 and this should be divided same smallest number here also 0.60. We would be end up with 1:1:2. Therefore your empirical formula will be selenium, oxygen and Cl2. That end up with 3 marks. Right, moving to the part E of the question. A sample of oxygen has a volume of 11.5 at room temperature and pressure. You have the 11.5 oxygen sample. The temperature of the sample decreased. Right, what you did was you had a oxygen sample 11.5 5 cubic decimeter oxygen sample. Oxygen molecules are there. Then what you did, the temperature of the sample decreased. You decrease the temperature. Keeping the pressure constant, you kept the pressure constant. Decrease the temperature. Describe and explain. You have 1 mark for that. Describe and explain. Using kinetic particle theory, what happens to the volume of the sample. You should know that when you decrease the temperature, so basic things, what is happening? When you decrease the temperature, particles gain very less kinetic energy. Or in other words, you can say kinetic energy of the particles decreases. Then the diffusion or the movement, particles move very slowly. So as the particles move in very slowly, question is asking what will happen to the pressure, volume. Right? As the particles are moving slowly, so the distance between the particles are becoming very closer because they are not moving very far away because they have lack of energy. Therefore, volume is going to be low. So then how do you organize your answer? But remember, it is only 1 mark. But as you have given 2 lines and asking describe and explain, you need to write kind of bullet points. So when the temperature decrease, so kinetic energy of particles decreases and particles move slowly or diffuse slowly. Therefore, particles are very close each other, very close. Volume decreases. Right. If you understand what to write, you will get full marks for the part 1. Right. Second part. Still you need to use the kinetic particle theory. The pressure of the sample is decreased. Now you see what did you do? You have a sample, oxygen sample, particles are there, pressure decreased. One way of pressure decreasing, you can increase the volume. Alright, pressure decreased, so you increase the volume. So that's how you decrease the pressure. The temperature remain constant. This time you do not change the temperature. Temperature remain constant. Describe and explain using kinetic particle theory what happens to the volume of the sample. Describe and explain using kinetic particle theory what happens to the volume of the sample. So, what happens to the volume of the sample when the pressure decreased? So, when you decrease the pressure, what will happen to the particles over there? Decrease in pressure means, so the between particles the space is very high. They move easily, they move randomly easily. So when you decrease the pressure, so what you need to write is when you decrease the pressure, particles move randomly and easily because space between the particle or distance between the particle, space or the distance between particles increases. So therefore volume increases. Right. Going to next one. Calculate the mass of oxygen. Calculate the mass of oxygen in 11.5 cubic decimeter sample at room temperature and pressure. Yeah. Importantly, like you have over there 2 marks. Remember to give 2 significant figures. This is the most candidates for getting part. 2 significant figures. Right. Only thing you need to know at room temperature and pressure. 1 mole of any gas should be 24 cubic decimeter. That gas molar volume. You are supposed to know that at room temperature and pressure. Then 11.5 cubic decimeter, you can find out how many moles of the gas. So that end up with 11.5, 1 moles per dm cube. So the cross multiplication. So therefore, number of gas moles are going to be 11.5 into 1 divided by 24. So you will end up with 11.5 divided by 24 is equal to 0.479. We'll go to the three decimal places. 0.479. So then question is asking, this is the number of moles, but question is asking the mass. So the once you know the moles, simple equation, n is equal to simple mr. So therefore m is going to be nmr. So the moles are going to be 0.479 multiplied by mr of O2. Remember, that is oxygen O2. That is going to be 32. So you will end up with 15.33 grams, because question is asking now give your answer to two significant figures. Therefore it should be 15 grams, because question is asking to two significant figures. Alright, moving to the question number 3 now. So the question number 3 about the polymers, right? Non-biodegradable polymers, right? Name the type of polymer shown. You can see the type of polymer. So that basically this is the repeating unit, right? You have the repeating unit. Type of polymer basically from the alkene. Therefore, obviously you do not have ester bonds. Obviously you do not have amide bonds. So therefore, definitely this should be a addition polymer. So if you have, as you know, ester bonds or amide bond, it should go for the condensation polymer, but here it should be addition polymer. So the structure of the monomer used to make this polymer. So once you identify the repeating unit, so as you know, you can take the repeating unit over there, carbon-carbon, and I have CH3 and hydrogen here, and H and Cl. Only thing is you need to put a carbon-carbon double bond. That is going to be your monomer. The polymer is often disposed by combustion. Suggest one problem associated with this method of disposal. So combustion, plastics, combustion, or the polymer combustion of addition polymers. Suggest one problem associated with this issue. So you are not supposed to be burn these plastic polymers. One basic problem is toxic gases. It releases toxic gases, so such as carbon monoxide. As you have the chlorine, it can be hydrogen chloride gas as well. So one problem is toxic gases of carbon monoxide HCl. That is enough for the 1 mark. Even if you can write like a carbon soot, for example, in addition to carbon monoxide HCl, that also create like pulmonary irritants or respiratory problems. So the respiratory tract issues, or you can say irritants. So better always write in the main thing toxic gases. You know, carbon monoxide is very toxic. It blocks the hemoglobin, oxygen transport. The structure of the lactic acid is given here. Suggest what is meant by the term biodegradable. Biodegrade, decompose or hydrolyze, biodegrade. So you can say breakdown, or you can say hydrolysis of the polymer, by means of degradation, like for example by microorganisms. You can give examples for microorganisms, maybe bacteria. Right. Going to part B2. Draw the partial structure of polylactic acid. So at least 2 repeat you need. Polylactic acid. You know lactic acids, when you consider the structure of the lactic acid given over there, it has carboxylic acid part and alcohol part. So therefore, it's undergo the condensation polymer. We'll see now, lactic acid structure has carboxylic acid part attached to alcohol part. So you have hydrogen over there and CH3 over there. If you combine with another lactic acid molecule, you have OH here and H here, CH3, and this is your acid part, COOH. Right. So then when you consider the condensation polymerization, OH and H releases water. At the same time, if you consider this alcohol unit also, it joined with another one and this OH also goes. So then what is left will be O, and you have CH, CH3, then you have C double bond O, you got an ester bond from here, then you have CH, again CH3 and CO, right? So you have the 2 units over there, first unit and the second unit. So that is going to be your answer for the asking. Show at least 2 repeat units of the polylactic acid. So then you will get 2 marks. Don't forget to show the continuation over the structure. Next one. A factory used 500 tons of lactic acid to make polylactic acid. The percentage yield 100%, but the mass of polylactic acid made is less than 500 tons. Explain why the mass of polylactic acid made is less than 500 ton. Explain. As you know, when you do this reaction, you will be getting water as a byproduct. So that byproduct is the reason for the lack of the total mass. So very simple answer is in condensation polymerization. In condensation polymerization. In condensation polymerization, byproducts are formed. Byproducts are formed. So such as water, for example. Therefore, polymer mass, final polymer mass is reduced, or you will obtain the lower mass. So basic answer is byproduct formation. Right. Going to the next part. Aqueous lactic acid react with acidified potassium manganate. You know potassium manganate is an oxidizing agent. That is an oxidizing agent. So in the aqueous lactic acid here, lactic acid has 2 functional groups. One is alcohol functional group, the other one is carboxylic acid functional group. There is a color change from purple to colorless. Okay, purple to colorless because this is purple color. Suggest what happens to the lactic acid in this reaction. Suggest what happens to the lactic acid. So lactic acid is oxidized. It is oxidized due to the presence of, the presence of alcohol group. It undergoes oxidation due to the, actually it's enough, it is oxidized due to the presence of alcohol group. Aqueous lactic acid is neutralized by aqueous sodium hydroxide. Write the ionic equation of neutralization. You know any acid-base reaction, you need to know this one every year in any paper, like every year it is asking. H plus OH minus giving you water. So any acid-base titration or any acid-base reaction, neutralization reaction end up with H plus OH minus, alkali and acid reaction. Aqueous lactic acid react with magnesium, name the gas made in this reaction. So obviously acid react with the metal producing hydrogen gas, but remember name is asking, therefore you need to write the word hydrogen. Okay, let's end up with the question number 3. Move into the question number 4 now. It's about the ionic compound zinc bromide and zinc carbonate. Are both ionic compounds? It's given they both are ionic compound. Predict the physical properties other than electrical conductivity. Right? Physical properties of, so remember very basic properties of ionic compounds. It has high melting point and high boiling point. Do not write these two as like separately. Make it high melting point or high boiling point, and they are solids. They are solids, or you have they are hard to break, hard structures, hard to break because physical properties are asking. Even you can write dissolve in water. In water. Right, 2 enough to get 2 marks. Zinc react with zinc bromine to give zinc bromide. Right, zinc bromide contains zinc plus 2 Br minus ions. So this contain zinc plus 2 and Br minus. Explain in terms of the movement of electrons. In terms of the movements of electron, how zinc bromide is formed. Zinc atoms and bromine molecules. Okay. So very basic question. Question is asking about how the ionic bonds are formed. Movement of electron. Right. Here I have zinc plus 2 and you have 2 bromine atoms. Right. To get 2 Br minus. Right. From bromine molecule, Br2 molecule, or you can say breaking Br2 molecule gives 2 bromine atoms, which so 2 bromine atoms are going to be which donates an electron, I think I'm wrong here. I need to do the correction. Right, actually what is happening there, we'll try to understand first. So I have to get zinc plus 2, I have to get Br minus. So basically what is happening, simple theory, zinc is becoming zinc plus 2 and 2 electrons going away. At the same time we are taking 1 electrons to become Br minus. So these 2 electrons are taken by 2 Br atoms, like becoming 2 Br ion. That is what I need to explain. Okay, you can start like this. Zinc loses 2 electrons and becomes zinc plus 2 ion. These 2 electrons are taken or gained by 2 bromine atoms forming Br minus. Right? Explain in terms of movement of the electrons. So it's better to now in terms of movement of electron explain. Still you can write one more thing. Then Br minus and zinc plus 2 attracts each other. Actually that is an electrostatic attraction. So 2 marks. Going to next one. Aqueous zinc bromide react with magnesium as shown. Zinc plus 2 magnesium, magnesium plus 2 zinc. Use the equation to explain that oxidation taken place. Oxidation. So you can explain oxidation in terms of increase in oxidation number, but that is not exactly in the syllabus, but it still you can write down oxidation number increase, or you can write in terms of electron transfer. So very famous one is oil rig. Oxidation is loss and reduction is gain. You see what has happened to magnesium. Magnesium became here magnesium plus 2 and 2 electrons are removed. So therefore you can say, use the equation to explain oxidation takes place. So magnesium loses 2 electrons. Therefore magnesium undergoes oxidation because losing electrons is an oxidation. Use the equation to explain the reduction takes place. At the same time, other one, zinc plus 2. Zinc plus 2 take 2 electrons to become zinc. So then you can say zinc plus 2 takes or gains electrons. Therefore, zinc plus 2 is reduced. Zinc plus 2 is reduced. Okay. If you want, you can write in terms of oxidation number. You will get the marks. So, magnesium oxidation number increased. Zinc oxidation number decreased. Right, moving to the other one. Question is asking, name a suitable aqueous solution that can produce carbonate aqueous ion. So, then the soluble carbonates are better. Like any alkali metal carbonates, like sodium carbonate, Na2CO3, sodium carbonate. But asking name, better to write the name. Sodium carbonate can be potassium carbonate. Alkali metal carbonates are better, sodium carbonates, because group 1 carbonates are soluble. A sample of zinc carbonate is heated strongly. Name the products of this reaction. Products of this reaction. Zinc carbonate, when you heat, you know, it's a decompose into zinc oxide and carbon dioxide. Therefore, name the products. It has to be carbon dioxide and zinc oxide. Right. That's the end of question number 4. Moving to question number 5 now. Last question of section A. Right. Moving to petroleum industry, crude oil provide raw materials for making ethanol and ammonia. Describe how petroleum, crude oil, is separated to make fractions such as naphtha and petrol. Okay, crude oil, you know, it's a mixture of mixture. So how do you separate the mixture? So the main technique, the method, fractional distillation. So that is required in your answer. Method. Then you require a principle behind that. Principle is basically different boiling points. So the fractions have different boiling point. Sometimes that is enough to get 2 marks, but we can still explain what is the process. So if you consider the naphtha and petrol, so the boiling points of petrol, as you know, and you should know this process, petrol is very much lower than naphtha fraction, naphtha. Therefore, petrol collects at the upper part, parts of the column. So it's further to these 2 points. So the petrol is having less boiling point compared to naphtha. So the petrol collects at the upper parts of the fractionated column. Or you can, so because we have very limited lines, I think that is enough. But still, you know the process. When you vaporize, so to the fractionated column, the vapor is entering. So when you heat further, vapor is moving upwards of the fractionated column. So the low boiling point fraction moves up and the less boiling fracture will distill down. So then in the fractionated column upper parts I can collect the petrol and the lower part is naphtha. Compounds such as C11H24, right? Explain how the molecular formula shows the compound is an alkane. Simple, because alkane general formula is CN2N plus 2. So in other words, if I take C11, it should be H24. 11 into 2 is 22 plus 2. Very simply you can say it follows, I mean C11H24 follows the general formula of an alkane. Right. Going to part 2. Construct an equation to show the cracking C11H24 to make ethene and an alkane. Cracking, decomposition reaction. C11H24. When you crack, so question says what to make? Ethene. So C2H4, ethene, and an alkane, probably the remaining part. So C11, 2, then what is left is C9. We'll consider the H should be 20. 2 into 9 is 18 plus 2, this is an alkane, 1 mark. Describe how hydrogen is converted into ammonia in the Haber process. Hydrogen is converted into ammonia in the Haber process. So 3 marks question. So what is to be written? Include conditions used in the Haber process. So the part of your answer should include this. In this kind of question, you need to organize your answer in order to get all 3 marks. It's better to write the equation. Like you have, sometimes you might get the equation mark, hydrogen gas and nitrogen gas. This indicates how hydrogen is converted to ammonia. So hydrogen gas, nitrogen gas in an equilibrium process convert into ammonia. So that is also gas. In order to balance you require 2, and this is 3. Right? So hydrogen reacts with nitrogen in a we have to use the catalyst. No, it is inside the converter. Right? We have the catalytic, like with the catalyst you have the actually the best word is reactor, reacting place. Okay, so now you said nitrogen is from air, nitrogen is from air, react with ammonia. Then give the condition. Under which condition? Temperature should be somewhere around 450 Celsius. If you write between 400 to 500, okay. Then a pressure, you need to say pressure should be 200 atm, and catalyst. So in the first catalyst you have to write iron as a catalyst will be using. Describe how hydrogen is converted into ammonia. Hydrogen react with nitrogen in the air in equilibrium reaction. Right? In an equilibrium reaction forming ammonia. So what are the reaction condition? Temperature, pressure, and catalyst is used, is given. So actually catalyst decreases activation energy. Actually it's the cost deducting factor, decrease in the energy requirement for the process. Right. This is how you convert hydrogen into ammonia. Next part. State one other use of hydrogen. So hydrogen has many uses. One other use is it used in margarine industry in the syllabus to form margarine industry. In the organic chemistry you will be doing. Then as in plastic industry you will be using plastic industry. Even will be using a green fuel in the rocket fuel as a rocket fuel. Right. Moving to the next part. Ethene react with a compound to make ethanol. Ethene reacts with the compound to make ethanol. So name the compound. So you know ethene react with steam, right, to form ethanol. State one condition for this reaction. So this is addition reaction. and you require the conditions like it is happening concentrated acid catalyst required H2SO4 as a catalyst, or we require 300 degrees Celsius temperature and 60 to 70 atm pressure. Write in at least one would be fine. Right. That's end of section A. Moving to section B now. So in the section B, so in this exam, answer 3 questions from the section in the spaces provided. The total mark for the section is 30. That means you have to select 3 questions out of 4. Right. We'll discuss the 6th question. It's about the sulfur dioxide and oxides of nitrogen are pollutants found in air. You know, sulfur dioxide, nitrogen oxides are pollutants in air. Part A. State 1 environmental problem caused by the presence of sulfur dioxide. So automatically you should come to your mind that sulfur dioxide in air environmental problem is acid rain. That is the main thing to be known. Actually, visibility of the air decreases in some areas. When heavy traffic is going on, visibility decreases. That also okay, but main thing is acid rain. Name the compound used in FGD. So what is FGD? That is going to be flue gas desulfurization. So for example, in sulfuric acid industries, industrial area, sulfur dioxide is going upwards and going enter into the air. So that can be minimized by reacting with chemicals. So you know sulfur dioxide is basically acidic. So combine it basic compounds will be limiting enter into the air. Name the compound used in FGD that react with sulfur dioxide. So basically that is going to be calcium oxide, even calcium carbonate is okay. Calcium oxide, calcium carbonate is okay. Both are reacting with sulfur dioxide. Right. NO is produced when nitrogen react with oxygen. Construct an equation. So you have N2 plus oxygen giving 2NO. N2 in air, O2 producing NO. They are not asking the physical state. Draw dot and cross diagram for nitrogen molecule, one of the famous with a triple bond. Nitrogen has a triple bond. Then draw in nitrogen molecule. So you have one atom and the other, say using dots for one nitrogen and the crosses for other things. And don't forget, nitrogen is group 5, therefore you have 2 electrons in outer shell. So now you got the nitrogen. So that is enough for the 1 mark. Explain why the rate of reaction. Explain why the rate of reaction between nitrogen and oxygen increases as the temperature increases. Question is clear. Question is asking why increase rate when temperature increase. So 2 marks. So you have to go for the kinetic energy. Then what will happen to the particles in terms of increasing rate. So when you increase the temperature, so kinetic energy of particles increases, therefore move very fast. In other words, you can say therefore frequency of successful collisions increases. We'll make like that. Frequency of successful collisions increases. Frequency of successful collisions increases. So that is enough for 2 marks. What did you write? Kinetic energy of the particles increases. Therefore, frequency of successful collisions increases. Therefore, rate increases, because it's the question. Rate increases. Moving to the next part now. Actually over here if you write more particles have more energy, more particles have energy greater than activation energy, that's also okay. Energy greater than activation energy, a bit A-level part. Some students are writing this, also acceptable. This is perfectly enough. Moving to the next part of the question. So you got a reaction. Construct the equation for nitrogen dioxide react with sodium hydroxide. You know acids react with bases. So the nitrogen dioxide, nitrogen dioxide is an acid, NO2, and sodium hydroxide is a base. And what to form? Form two different salts and water. You can get the idea now. When NO2 react with water, you get HNO2, HNO3. Therefore, when NO2 react with sodium hydroxide, you will get sodium nitrite like this, plus sodium nitrate like this, plus water. Okay, you got the basic compounds. Now only thing is you need to balance the equation. So in balancing, what you need to do is check the nitrogen. This side you have 2 nitrogen, I'll put here 2. Then this side you have 2 sodium, keep in 2 here. We'll check whether hydrogen balance, 2 hydrogen, yes, oxygen will be 2, 3, 4, 5, 6, 2 into 2, 4, 5, 6, yes, it is balanced. Nitric acid is a strong acid. Nitrous acid is a weak acid. Nitric acid, nitrous acid. So this is your nitric acid. We'll see the question now. 2 marks. Describe the differences between weak acid and strong acid. Okay. Weak acids and strong acid. So better to write for both. Strong acids. Strong acids are ionized fully or completely in water. Strong acids are ionized fully in water. To complete the acid part, giving H plus ions. Other one, weak acids are going to be ionized partially or incompletely in water. Completely opposite of this answer. Fully, partially in water, giving H plus ions. So that is end up of first question of the section B. Moving to the second part, that is going to be second question. Seventh question, which is in the second question in section B. Like sulfamic acid NH2SO3H is a white crystalline solid. So this is a white crystalline solid. It reacts with aqueous sodium nitrite to make nitrogen gas as given in the equation. Right. So what the question? An excess of sulfamic acid, this is in excess. React with 20 sample of 0.1 sodium nitrite. Calculate the maximum volume of nitrogen formed. Maximum volume of nitrogen is formed. So as the sulfamic acid is in excess, disregard the excess reagent, we'll go for the limiting reagent. So we'll find first number of moles of sodium nitrite. You know it is concentration given, volume given. We can use C is N over V equation. So N is going to be CV. Then you have the concentration which is 0.150. Volume is divided by 1000 in order to convert into cubic centimeters. Volume is going to be 20. So when you calculate this one, you will end up with 0.15 into 20 divided by 1000 is equal to 3 into 10 to the power minus 3. that end up with 3 into 10 to the power minus 3. Now consider the equation. In equation it says 1 mole of sodium nitrate giving you 1 mole of nitrogen as well. Therefore, if you know this moles means you know the nitrogen moles also. In other words, this is also nitrogen gas moles. Question is asking the cubic decimeter. This is the moles. What is the volume of nitrogen formed in cubic decimeter? And you know 1 mole of any gas is going to be 24 cubic decimeter. Therefore, 3.10 into 10 power minus 3 will be 24 into 3 into 10 to the power minus 3 moles. So that is going to be a final answer 0.72 cubic decimeter. They are not asking anything about the significant figures. 2 decimal points would be enough. Going to next one. The rate of this reaction can be determined by measuring the volume of nitrogen every second. Draw a label diagram of the assembled apparatus that can be used to collect and measure the volume of nitrogen formed. They are not asking anything about how to calculate rate and those things, but very simply, you know, rates are calculating, draw in graph, volume of gas, maybe nitrogen with time. Therefore, I need to measure time and the volume. So, question is asking not how to measure time. Question is asking how you are going to measure the volume with time, right? I mean, how do you measure collect and measure volume? So, it's a very basic question. So, that need to be with the gas syringe, because usually you can measure with the gas syringe. I think this is the large one. We'll go for the smaller one, right? So we need to have a gas syringe. Okay, so in the gas syringe you need to show in the exam the markings. So you have the gas volume. So this is gas syringe, and question is asking label diagram. Therefore it is necessary to make the label. So this is going to be your gas syringe. So labeled diagram. So the gas syringe should be connected to the reacting vessel. Basically, we have in the reaction you have chemicals, only 2 things. These are the 2 things, this one and sodium nitrite. Therefore, we can use a titration flask for the reaction as a reacting vessel. So we'll be using this one. That it should be airtight, otherwise you can't collect the gas. And this is your vessel. This kind of a vessel would be fine, and the reactant volume is there. So this is going to be your conical flask, or you can say the titration flask. And these are the reagents you have. What are the reagents you have? You have NH2, SO3, and you have sodium nitrite. So I think that would be fine enough for 2 marks. Then at the same time you can label delivery tube. Actually not necessary. So you have gas syringe, conical flask, and this is how you do to get 2 marks. Going to next part. The concentration of sodium nitrite is increased. Sodium nitrite concentration increased. The temperature remained constant. Then how to get the rate of the reaction? Actually, this is the second part asking about the factors affecting the rate in this paper. When you increase the concentration, you see you get 3 marks again. So you need to explain when you increase the concentration. When you increase the concentration, what will happen? Number of particles per unit time, per unit area, or per unit volume increases. Number of particles per unit volume increases. Like when you increase the concentration, say you have in this volume and this volume, same volume. Here low concentration to 4 particles. But if you increase the concentration, number of particles will be very high. Number of particles increases, high concentration. When the number of particles are increasing, you can have many collisions per unit time. Therefore, frequency of successful collisions, frequency, that means number of successful collisions, frequency of successful collisions increases. Frequency, number of collisions of successful collisions increases, therefore rate increases. Right, there will be more collisions basically because more particles, so 3 marks. A sulfamic acid forms salts called sulfamate that contains this anion. Magnesium carbonate is added to sulfamic acid. Magnesium sulfamate, water and a gas are formed. The gas turns lime water milky. Construct the equation for this one. So you know acid react with the carbonate to form carbon dioxide. So that is what main thing asking. We'll try to write the equation now. Any carbonate produce carbon dioxide. So magnesium carbonate. Your acid this time is NH2 SO3H. So producing magnesium salt. So the salt is given to you. -1 charge, but magnesium +2 charge. Therefore this will be NH2 SO3 2 times plus water and a CO2. Okay, you have 2 over here for balancing. So you got the carbon dioxide, water and the salt. That's the question number 7. Going for question number 8 now. It's about the lead. Lead is a metal with proton number 82. It's a metal. It's given as a metal. Use the periodic table to state the number of occupied electron cells in an atom of lead. Occupied number of cells. The part 2 is asking state the number of electrons in outer shell. So in other words, question is asking, you know, number of outer cells goes to the group number. And this is asking the period number. So basically what they are asking, so where is the lead in your periodic table? Then identify the period as well as the outer shell. So the periodic table is given in your question paper. So if you consider the last page, you see. So the periodic table is given. So lead is over there. So lead is in group 6. Therefore, group 4. Lead is group 4. Therefore, its valence shell has 4 electrons. Now the period. Period number 1, 2, 3, 4, 5, 6. Lead is in 6th period. Means it has 6 cells. 6 occupied. 6 cells with electrons. So therefore, answer for the question number 8 part A. Question number 8 part A will be use the periodic table to state the number of occupied electron cells in an atom of lead. That is going to be period number 6. This is going to be group number 4. Next part. Another famous question in a paper. Describe with the aid of label diagram the metallic bonding in lead. It's a metal. You know metallic bonding, you have the metal atoms in a sea of electrons. So the same size but nicely arranged because it is a lattice structure. So at least 2 layers would be fine in the same size. Lattice structure, but remember everywhere without any pattern you have the delocalized electrons. Right. You have the delocalized electrons and the labeling required. This is going to be metal ions or atoms Pb plus 2. At the same time you have delocalized electrons. Delocalized electrons. Right. Describe with the aid of a label diagram the metallic bonding. So this is the label diagram. So then what is the metallic bonding? It is the electrostatic attraction. Electrostatic attraction. It is the attraction, a force between metal ions and delocalized electrons or mobile electron, delocalized electrons. So 3 marks. You give the diagram and you give the metallic bonding. It's the electrostatic attraction between metal ions. You know, Pb plus 2 positive charge plus 2 and electrons negative, attract positive and negative. Going to next part. Give 2 physical properties of lead that are characteristics of metal. Metal properties. Metals have high melting point and they have high boiling points also. Metals can conduct electricity. They can conduct electricity. Metals can conduct electricity and metals are having high density. That is also correct, and they are malleable and ductile. So only one is required to get, 2 is required to get 1 mark. Lead to ethanoate is a white crystalline soluble salt. White crystalline soluble salt. Name a suitable combination of an acid and insoluble base. That means oxide, which is used to prepare lead to ethanoate. You know, ethanoate is from ethanoic acid. Name is asking. Acid will be ethanoic acid. Because in order to get ethanoate, you need to have ethanoic acid. And base should be lead oxide. So that is going to be lead to oxide or lead oxide means PbO, because PbO plus ethanoic acid, which is CH3COOH. PbO with CH3COOH, you will end up with lead ethanoate means PbCH3COO minus ethanoate, right? This is plus 2 plus PbO plus water. So you will get lead to ethanoate, white crystalline soluble salt from ethanoic acid and lead to oxide. Right. Moving to the other part, part E. Aqueous lead to ethanoate react with aqueous sodium iodide. Sodium iodide, lead to ethanoate. A yellow precipitate of PbI2 is formed. Construct the ionic equation with the state symbol for this one. It's a very famous reaction with iodine. PbI2, it's a white precipitate. It's going to be solid. Question is given, yellow precipitate. How do you get that one? In order to get this precipitate, what we require is we need Pb plus 2. So Pb plus 2 solution, therefore it should be aqueous, and I required I minus from sodium iodide, aqueous, and you require 2 of them, PbI2. Explain why solid lead iodide cannot conduct electricity. No, actually asking why cannot be electrolyzed in solid. You know the solids cannot be used for the electrolysis. You have to heat it to get the melting molten form. So therefore, why is that? In solid form, ions are fixed. You know this is ionic compound, therefore ions are fixed, cannot move to carry charges. So that is why you have to melt it. Going to the next question, question number 9. That's question number 8. Question number 9 goes to the organic question. It's having the formula ethyl propanoate. You have alkene part propene, alkane part OH, ester part. Circle the atoms in the structure that shows that ethyl propanate and ester. Okay, this is the ester atoms. Ester bond is this one, including this is your ester part. Right, next one. Aqueous bromine is shaken with sample of ethyl propanoate. Explain in terms of the structure. In terms of the structure, why the aqueous bromine turns colorless. Right. In the structure, carbon-carbon double bond is present. Right. Which undergoes addition reaction with bromine, or you can say bromine is added to the carbon-carbon double bond. That is why color change happen. Right, you got an ester formation reaction. This is ester and water form. From esters, forming by carboxylic acid reacting with alcohol. Name the alcohol you see in this reaction. It is going to be ethanol. Next one. The reaction uses an acid catalyst. State the effect of the catalyst on the position of equilibrium. In general, catalysts have no effect on equilibrium. No effect on equilibrium. So in general, you need to know catalyst only does decreases activation energy. It decreases activation energy. It has no effect on enthalpy, delta H, and even the activation. It decreases only activation energy. No effect on equilibrium. Part 3. The concentration of the alcohol is increased. So this is an equilibrium reaction. If you increase the alcohol concentration, describe and explain what happens to the position of equilibrium. You see, if you increase the alcohol concentration, system wants to decrease it. According to the Le Chatelier principle, it wants to decrease the concentration. To decrease, equilibrium position shift to the right hand side, because added increased amount should be decreased quickly. The reaction is happening towards this side. So how to organize the answer? Part 2. Describe and explain. When you increase the alcohol concentration, equilibrium position shifts to right hand side. It shifts to the right hand side to decrease the concentration of ethanol, to decrease the ethanol concentration. Okay, so the concentration, alcohol. Describe and explain what happens to position of the equilibrium. Equilibrium position shift to the right hand side to decrease the ethanol concentration, to minimize the amount. Next part. In an experiment, 10.8 gram of carboxylic acid is react with excess of ethanol. You react with excess of ethanol. The experiment yield ethyl propanoate 9.4 propanoate. Ethyl propanoate as 9.49 gram. Relative formula mass of carboxylic acid 72. Show that the maximum possible yield of ethyl propanoate is 15 gram. Maximum possible yield ethyl propanoate is 15 gram. In this case, first we'll calculate the number of carboxylic acid moles. So the carboxylic acid moles is going to be mass over MR. So you have the mass at 10.8 divided by 72. You will end up with 0.15 moles. So when you use the carboxylic acid, so you know the acid, alcohol, react with alcohol, giving you ester and water. All the molar ratios is 1:1 and giving 1:1. So therefore, if you know the acid amount 0.15 mole, means you know the ester amount as well. Therefore, number of moles of ester produced, ethyl propanoate is also same, which is 0.15 moles. Then you can calculate the mass of ester produced. So if you react like this way, so the mass of ester produced will be 0.15 into the mass. Mass will be, right, you will require the ester MR. So we require the ester MR this time. Ethyl propanoate MR you need to find. So what is the MR of ethyl propanoate? Show that the maximum possible yield of ethyl propanoate is 15 gram. Then you need to ethyl propanoate MR. So the ethyl propanoate structure is given here. This is your ethyl propanoate, right? Ethyl propanoate. So over here also given ethyl propanoate 1, 2, 3, 4. You have carbon. How many carbons? 1, 2, 3, 4, 5 carbons. Then you have hydrogen. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogen. You have 1, 2 oxygen. 1, 2, 3, 4, 5 carbon. 8. Okay, then you need to find the mass. Carbon 12 into 5 times plus 8. This is oxygen 16, 32. We'll get the MR. So you have the 12 into 5 times. Then you have plus 8 plus 32, end up with 100 MR. So the relative molecular mass is going to be 100. So that is the relative molecular mass of the ester that will be used in your calculation part. So in the calculation we required here 100, you will end up with theoretically 15 grams. That is what we need to prove here. Hope you understand. First of all, find out the carboxylic acid moles. M over MR you get 0.15 moles. So 1:1 reaction, therefore ester moles also same. Mass of the ester 0.15 into 100, 15.0 gram. Calculate the yield, percentage yield of ethyl propanoate. You know, percentage yield is equal to mass obtained practically. Practical mass over mass theoretically what you expected. So over here you have practical mass. You got the ethyl ethanoate 9.45. You got only practically 9.45. Then theoretical mass is going to be 15.0 into 100 is going to be percentage yield. That end up with 63%. Right. That's the last question. This is end of the paper discussion. I hope you understand. And feel free to discuss about the theory or the any unclear parts. I would be very happy to discuss it again and make the corrections. And we'll meet with another video. And please subscribe this and share this video with your friends and teachers so that they also get benefits. Thank you very much.